I love solving problems, and if you are accessing this video, then you do too, or you love to listen to videos, or and watch videos, or you just want some hints. Well, here we go. This is a compound area because we got a big rectangle and we're taking away essentially two circles. So this is, I'll draw a picture here. We want to have a big rectangle and then we take away two of these circles. So the big rectangle, okay, we've got the radius is 8, and that means this rectangle is 16 high, and then the radius can swing here or here or here, and then across to here, and then across to here, and then across to here. So we're looking at essentially 4 radii long rectangle, which is 32. Okay, so we need to find the area of that. That's simple. Base times height. Then the two circles, each of those circles has a radius of 8. And by mean 2, I'm just taking this one. I'm going to stack it over here because two semicircles of the same size are one circle. Area is pi r squared. So the area of one of those circles is 64 pi. So it's really, I'm taking away 128 pi. Can you take it from there? I don't have my calculator with me. Number 5, the arc of ACB. Okay, so we've got, this is going to be nice. It's just a quarter of a sector. So that means ACB, which is this thing out here, is going to be 3/4 of the whole circumference. So I'm really taking 3/4 of the circumference. Circumference is pi times diameter, so that is 10 inches diameter. 10 pi diameter. So we're really looking at 30 pi over 4. I look to my answer and I see that it is in terms of pi, so I just need to take 30 cut into 4. That's really 15 over 2. That's really 7.5 pi. That should get you what you need. Now this sector, it's still 3/4 of something, but it's now 3/4 of the area. So we want 3/4 of the whole area, and area is pi r squared. That is 25 pi. So we're really looking at 75 pi over 4, and in this case, round to 1 decimal place, I'm using, now I have my calculator, I was just fooling you before, 75 pi all divided by 4 should be 58.9. Number 6 is quite similar because it also is the arc length of a sector, or the arc length of a circle, and then the area of a circle, but now it's 150 degrees. Let's analyze that. 150 degrees out of 360 total is like 15/36, which is, let's see, I can't divide by 5, but I can divide by 3, 5/9. So ACB here, oh, and now we are looking for ACB. That part is 5/9 of the circumference, and that sector is 5/9 of the whole area. So this is going to be very similar to number 5, except where it used to be 3/4, you're using 5/9, and the radius is different. Okay, sorry, I got an interview in a few minutes, so that's why I'm rushing ahead on this one. But I think you're getting the gist of it. I like this one because it's about pizza. Your group of students has a total pizza for $10.80, and you have a slice that's worth $2.25. So $2.25 is to the whole 1080, in the same way as your circle sector, don't know what it is to the whole circle in degrees. Proportions are key to life. and they really help out in math. All right. Now this number 8. Here's the outfield in Oracle Park. Let's see. And here's the infield. Imagine that we've got this big. Let's pretend like we have the whole big circle. So it's the. And we're actually going to take 1/4 of it, but let's do the whole big circle. Let's see, area of big circle minus area of small circle. This one is tough because I think we have to keep pi till the very end and then go from there. So the big circle would be, area is pi r squared, so it's pi times 339 squared. The small circle is 130, so that's pi times 130 squared. And now let's go and make this formal because it's going to be just 1/4 of that circle. So I'm going to now have 1/4 of 339 squared pi minus 1/4 of 130 squared pi. Check my math. I get 28730.25 pi minus 4225 pi. That should be a minus. And I'll let you take it from there. You're going to get something, because these are like terms, in terms of pi. You're going to use the exact number for pi and then round to the nearest square foot.